Hi, this is JR. This is Monday morning, and I'm going to talk a little bit about some thoughts I had, I think just this morning. Last night I was listening to Dan Nelson speak about spin and the subatomic properties of spin as it relates to quarks, and you put spin and a few different other characteristics together, and you can get protons, you can get electrons, you can get neutrons, you can get these different subatomic particles by putting together different qualities. And one of the qualities he was talking about was spin. And one of the issues he was talking about was adding spin or increasing spin, as in, he didn't say this, but as in speeding up the spin. So he mentioned spin axis, and then we can also imagine the idea of the speed of how fast something is spinning. So we're talking here about the spinning of energy. So we want to differentiate. We're not actually talking about matter spinning, but energy spinning. When you spin a magnetic field, that produces current. Now, that's just something that I have been exposed to over and over, so I think, okay, that's kind of a basic thing. So we were talking about the spinning of energy. However, it's useful to talk about, to use a material example. And of course, my perspective is that when we're talking about matter, we're talking about a particular form of energy. The forms of energy are radiating energy, solid energy, as in solid crystal energy, liquid crystal energy or plasma, liquid energy, and gaseous energy. So those are all forms of energy. So if you have a battery acid, we could say, okay, that's liquid, but it's energy. If we have fat or carbohydrate, we think of those as forms of energy. If we have a flame, we could say, well, it's in a form of gas, but it's energy. If we could have a really hot rock, like we put something in the oven and it comes out of the oven and it's really hot to touch. It may be solid. You know, the little metal bars in the oven, you don't want to touch them because they are extremely hot. The pan that's been in the oven is extremely hot, but it's energy. It's not that the pan has energy, it's that it is energy, and the particular form of energy it's in is actually radiating heat. So it's accumulated heat and now it's radiating it. So this idea that there's matter and energy as two separate, these things that are not continuous with each other, that idea is in question here. So the example I thought to give, the first thing I thought of was fan blade spinning. The second thing was water, like when you have a whirlpool of water or a vortex of water, like maybe you fill up a sink and then you pull out the stopper, and what happens? The water makes a little whirlpool, a little vortex, and you may have seen those in the ocean or some other natural form of water. You can have multiple vortexes in the same body of water, in the same bathtub. So we always see water go the same direction in terms of, if we're in the northern hemisphere of the Earth, it always goes in the same direction. We know that the spin of the vortex of water is related to gravity and it's related to the energy of the Earth. What I wanted to say about the case of water is if you've got two vortexes near each other or several vortexes near each other, one of the things that can happen, you may realize, is that the spin and energy of each vortex will have a tendency to merge into a single bigger vortex. I'm just going to leave that to your imagination and assume that you can take in that idea. So you can have a variety of spinning vortexes or little whirlpools, and if they get close enough to each other, they're going to get close fast, and they're going to actually merge into a single thing. And we could call that gravity. So if a pocket or a system of energy has the same spin and is on the same plane, then they can quickly merge. Now if you have one thing spinning like this and going that direction, or stable and no motion or whatever, and one going like this, well, those will tend to repel each other, or they aren't going to, it's not going to just boom line up. If they're lined up with their exact spins are the same, and then they get close together, then they're going to merge. But in other cases, they won't merge. They will actually have a repulsive tendency or an interference pattern, which can actually disrupt both of the two systems of consistent spinning. So we can have a positive charge, a negative charge, and then a lot of different kinds of charges that we might call neutral or fractional charge. In space, we have 360 degrees in two different axes. On the Earth, like I mentioned with the hemispheres of the Earth, you can have a vortex pointing straight to the Earth with one spin, or the opposite spin. It's either spinning straight down like clockwise, or spinning straight up like counterclockwise. It's just got those two as the main things that we would say that's a stable piece of matter. It's not. It could be going up or just sitting there, but it's not. However we put these things. Maybe that's a positive charge and that's a negative charge, and then there's all kinds of matter that are floating around like in a satellite that are revolving around the center of the Earth in that case. So a satellite, you could have satellites at a bunch of different altitudes, and they're all going to be rotating around the Earth. They're going to have a bunch of different trajectories and directions. So that's the really complex layer, where there's lots of different directions, lots of different speeds, sizes, mass, and so on. We could call that material. And then you've also got a spin straight up, which can be steady. It can be rising. Typically, if something's spinning upward, it's not going to be falling, but that is also possible. And you could have things with the opposite spin. It could be rising, it could be steady, it could be coming down relative to the spatial point of reference of the center of the Earth, or the center of an orbit. So you've got positive charge, negative charge, and then all sorts of forms of matter. So that doesn't say, other than that when two of those little systems of spin come together, they can merge, increasing charge, they can neutralize charge, they can disrupt each other's patterns, they can form into, like, you can have, in the case of matter, you can have two pieces of matter going along a similar plane, or even kind of nearby each other, not quite the same plane, but they can end up bonding. So they can end up merging as well, or they can end up bonding. So there's a variety of things that could happen there. By bonding, I mean you have two distinct spins that are not on the same plane, that like a spin that's like this and a spin that's like that, and they could actually get together and typically it might be with a number of different spins. They can all mass together in some kind of stable cluster and move. That's kind of an odd idea, but that's one idea. With fan blades, briefly, you can have a fan blade turned off. They look like they're just sitting there. You turn it on at a low spin, and you can see the individual blades moving, but it's hard to see. Turn it up to a higher spin, and it looks like it's just one circle, one solid spinning something. So that motion gives it the appearance of a larger, that it's bigger. You take the same thing, it's like you take a string and you spin it around, and you have, you know, a big circle or a rock at the end of a string, or a rock tied to a string, and then you spin that around. Well, all of a sudden you have a huge area that's being covered and is within that energy field, or that area. And anything that comes within that area is going to interact with the momentum and energy of the string and the rock. If it lingers in that field, in that space, in that area of activity, it's going to interact with the matter. So you can imagine there's a variety of different speeds of spin, frequencies of spin, mass of spin, all that kind of stuff. Just kind of setting a framework that when you take energy and do something, and there's something consistently happening, it's a stable pattern of energetic activity that can manifest with a positive charge, a negative charge, a repulsive or attractive energy. It can manifest as something with a tremendous amount of speed. It can manifest as something moving slowly, depending on like how far it is from the orbit. How much energy and speed does it take to maintain the orbit, rather than to be drawn into the gravitational field, to be pulled in eventually, slowly or quickly, to be pulled into the central vortex, so to speak. What I'm talking about doesn't really cover what space is or what time is, but it does start to set up some of the framework for how spin and spinning energy is actually, we could also say vibration or frequency. How vibration, frequency, spinning energy is the foundation of all different forms of what we call matter. And again, when that fan blade is spinning really fast, you put you put some object into that path of the fan blade, and it's like matter. It's like the whole thing is solid if it's spinning fast enough. Now, could it be just a single string? You know, we have those weed trimmers where you have the little thing, you turn it on, it's just a little string that spins, and you can use that to trim bushes or to trim grass or to trim curbs, so you've got a really fast spinning string or a really fast spinning electromagnetic field. You can take an electromagnetic field and think of it as a string and spin that string around of really powerful electromagnetic energy, and then you bring anything else into that area where that electromagnetic field is rotating through it quickly or slowly. Well, it's going to affect the other fields that it interacts with, the other systems that it interacts with. So this is a somewhat coarse and simplified setup, but these are the kind of things I'm thinking of in today, that I've had some of this special water that I've been mentioning in other videos, and the kinds of things I'm thinking of. It took, like whatever, 14 minutes to explain a thought that took very little time to actually get, but to actually express it took quite a while. The idea that everything is connected and that there's orderly pattern and there's no discontinuity, that idea is really sinking in. So the idea or theory of discontinuity is one of the prominent linguistic models that I've been presented. There is such a thing as discontinuity. There's distinction. We know there's spectrums of light, but is there a discontinuity between yellow and orange, or between yellow and mustard? The idea of discontinuity is fundamentally odd. Consider that there is absolutely no physical evidence for the existence of a discontinuity. Matter is energy in a variety of forms. That energy can be released, that energy can be concentrated further and increased by adding charge. Electromagnetic charge can be added to a chunk of a magnet. It can be discharged, charge can be added. You can take some liquid that's acidic and increase the acidity of it, or decrease the acidity. You can connect a wire to it and run some current out of it. There's all sorts of things that can be done. But the idea of discontinuity is fully in question, or at least partially in question at this point. Hope you enjoyed the video. Thank you.